Rolls-Royce has been busy building this nuclear microreactor. It's a whole new classification of reactor, and one the company says could eventually provide power for NASA's planned base on the Moon.
We are in a new space race. There's a lot of commercial opportunities, but also agencies having aspirations to go to the Moon, stay there and beyond. So what we're looking at here is a scale model of our microreactor core system, core technologies.
Perhaps better known for its engines, British engineering firm Rolls-Royce has spent more than 60 years quietly building the power plants for the UK's fleet of nuclear submarines. The experience, it hopes, will help it compete in the new space race, according to engineer Matthew Marriott.
There's a lot of commercial opportunities, but also agencies having aspirations to go to the Moon, stay there and beyond. But really, in order for everyone to do that, they need power and reliable power. There are power options in space, solar electric being a good opportunity, but there are instances where solar isn't a viable option. It can't deliver you the power that you need for space. So this product that's sat here behind me will enable all of these companies to realise their ambitions in space.
NASA plans to establish a base on the Moon as a stepping stone for eventual human expeditions to Mars. Astronauts would go there to learn the skills needed for deep space missions. Sustaining human life and a habitat on the Moon requires a serious amount of power, which is where products like microreactors come into play.
2 years ago, if you'd said to me we'd be looking at designing reactors to go on the Moon, I'd have said that you were absolutely barking and it was a crazy idea.
Abby Clayton is Director for Future Programmes at Rolls-Royce.
When you think about Mars, is a really, really long way away, so it can take up to 18 months effectively to travel to Mars using conventional types of fuels. If we kind of use the power of nuclear to do that, you can probably cut that to around a 3-month period to travel to Mars. So it actually makes that planet more accessible for us to actually go and explore, make sure that we can do experiments there, but again also work out, can humans get to Mars? And that's certainly the plan. By 2040 is a target out there to get humans on Mars.
Microreactors designed for space will also have plenty of uses on Earth too, says Gary Jones, Head of Manufacturing Innovation.
It can be used for disaster relief, so you could actually transport one of these systems in within a short time frame, hours rather than weeks, to re-establish a grid, and then you could have power from a box that would really help disaster relief. You could also replace diesel electric generators to help decarbonise a multitude of applications on Earth. And you could also use it as a main powertrain for shipping, for example.
Rolls-Royce say they plan to have a prototype microreactor operating by the end of 2028.
I am not Morgan Freeman, and what you see is not real. Well, at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive? If you can see, hear, taste, or smell something, does that make it real? Or is it simply the ability to feel? I would like to welcome you to the era of synthetic reality. Now,